I'm very red today, actually. And that's for good reason, is because I'm going to be speaking about something that is probably in this, which is cranberry juice. The chemical in question is called resveratrol. Now, it's a tiny little chemical that's made in things like berries and pomegranates and grapes and red wine. Now, they release this chemical in response to stress. And you would be thinking, how does a plant get stressed? I was thinking the same thing, but apparently plants get stressed. And apparently plants get stressed because of UV radiation and fungus attacks. So when a plant gets attacked by fungus, it will release a chemical. That chemical is resveratrol. If we look up on Google what resveratrol actually does, apparently it does some pretty amazing things. Now, it can lower your blood pressure, it can reduce your cholesterol, it can lengthen your lifespan by 60%. I mean, if that's true, and it does lengthen your lifespan by 60%, I am wondering why everybody on the planet is not drinking this like crazy. Because apparently we can live till 160 if we take this, according to Google. It can protect the brain from Alzheimer's, it can increase your insulin sensitivity, it can protect against oxidative stress, and it can decrease your inflammation. It can suppress your cancer cells. Like, this is insane. Everybody on the planet should be drinking resveratrol or taking this supplement. But is it legit or is it shit? I wanted to find out. This channel is dedicated towards providing you the highest quality science in order to make decisions about supplements and where you spend your money. There's a lot of bullshit in the fitness industry, and I want to bring you the highest quality research in order for you to make an informed consumer decision about what you spend your money on and whether the supplements you buy are actually going to help you with your fitness goals. So, like I said, as I screw on the top to my pomegranate juice here, trans resveratrol is produced from isolating it from primarily red wine or grape extracts. Now, we have to wonder, how did this all come about? Well, in the 1980s, some scientists looked into why the French population seemed to be protected against heart disease. If we look at this graph here, despite the French population having just as much fat intake as other countries, they seem to be protected against some forms of cardiovascular disease, which was very odd because the French diet is quite high in fat. They eat a lot of fish in the Mediterranean diet, a lot of nuts, a lot of avocado, olive oil, but for some reason, the French were protected against heart disease. So scientists were thinking, what is it about the French diet that may potentially protect them against heart disease? And is there something in the French diet that is protecting them against cardiovascular disease? This was also paired with another theory that was the caloric restriction concept. Now, this was done in a very famous study where two scientists had put multiple animals together and had actually found that restricting the calories of the animals by up to 50%, those organisms lived longer on average than the ones that were not restricted to calories. They thought it had something to do with reducing oxidative stress or cardiovascular stress or tissue damage or DNA damage, but they weren't exactly sure why restricting calories in these organisms, almost without fail, like every single time, reduced their risk of cardiovascular disease, but also increased their lifespan tremendously. And yet there was a problem because people love their food. People love their food in the West. People love their drink and their food. So making a marketing campaign saying, everybody, you need to stop eating because that will make you live a bit longer, probably isn't going to go down very well with 99% of general population who love their food and want to eat. Now, they were thinking, okay, so making a marketing campaign about not allowing people to drink, eat, or do anything is probably a bit of a dumb idea. But maybe there's something in the French diet, if we bring the two theories together, that is protecting them against cardiovascular disease and may also mimic the calorie restriction concept without actually having to calorie restrict. So the scientists were thinking, all right, we can't have people calorie restrict because nobody's gonna like that and people are gonna tell us to stick it up our asses, but maybe we can mimic some of the calorie restriction benefits with a certain supplement if we investigate the French diet a bit more. So that's what they did. And people in France were saying, oh, well, we drink a lot of red wine, so maybe it's something to do with that. And the scientists went, huh. So they had a look. And they found resveratrol in red wine, which was a really potent antioxidant. And so resveratrol became a primary target of research throughout the 1980s and 1990s. And just this little molecule in the first early studies was shown to protect against cancer in mice, mammary glands, and skin, protect against plaque development in various animals, enhance nitric oxide production. Now we know nitric oxide production is a key vasodilator of arteries, which does reduce blood pressure. So that was huge. They also found that it reduced inflammation in arterial walls of mice. They found it decreased oxidative stress levels. And in humans, at a low dose of 10 milligrams a day over 3 months, the humans had a decreased LDL, which is bad cholesterol. So their cholesterol improved. But were these studies actually true? So they had put them together, but was it just cause and effect? Like, was it something else causing this? Or was it actually a true statistical relationship? They wanted to find out more, and the research shifted from observational studies to actual biological pathways. Now, when the research shifts from observational studies and like just some vague hypothesis to like looking at biological pathways, that's when you know it's serious, and that's when you know they might be actually onto something. So that's what they started to do in the 90s and early 2000s. And by 1999, scientists had discovered something called silent information protein 2. That sounds really badass, like it's from a movie or something. But in yeast, they found this, and it was a protein that was a regulator of gene expression. Now, this was very interesting. So they had found a protein that regulated how genes were expressed in yeast. So extra copies of the protein in yeast actually meant yeast lived longer, whereas removal of that gene from the yeast, so if they actually took silent information regulator 2 out of the yeast, it decreased their lifespan by 50%. So pretty much it was like this was a sensor in the cells that could regulate gene expression based on how the cell was doing, like metabolically, and just generally based on the health of the cell, it could then regulate gene expression. This was further highlighted in the fact that in the same study where they had changed the glucose of the environment, the yeast actually regulated that cell's ability to uptake glucose in a different way. When they removed glucose from the yeast concentration, so effectively what they were doing was calorie restriction for the yeast with the silent information regulator 2 protein increased their lifespan. But when they did the exact same thing, but in the yeast that didn't have any silent information regulator 2 protein, the yeast just didn't live longer at all. So in a way, this silent information regulator 2 protein had an ability to regulate the cell gene expression based on the environment around it, which was very interesting. So they wanted to find what was the equivalent of this SIR2 in mammals, because if we could find the equivalent in mammals, it may be a key indicator that there's something in our cells that can regulate gene expression and be turned on or off based on the environment of our cells. Well, they did find it, because we have 7 of them. We have SIRT1 through 7. And the earliest studies showed that in mice with an overexpression of SIRT1, they were leaner, more metabolically active, had better glucose tolerance, lower levels of DNA damage, and decreased aging markers, as well as, most interestingly, ding ding, fewer cancers. So with SIRT1 demonstrating all these positive effects, they wanted to find what activated this SIRT1 protein to exert these positive benefits on gene expression. So in 2003, guess what they found? Resveratrol, which is not actually resveratrol. This would have some in it. It's not a pure form, but resveratrol activated SIRT1. So they found that it was a very potent activator of SIRT1. In mice that were fed high calorie diets, resveratrol supplementation at 25 milligrams per kilogram per day protected them against high calorie diets. So we already knew that high calorie diets should have reduced their lifespan of the mice, but resveratrol supplementation protected them against a decreased lifespan as a result of the high calorie diet. Not only this, but the older mice started to have similar changes with gene expression that mimicked the younger mice. So in the older mice, they should have expected things like bone fractures, cataracts, age-related motor coordination difficulties, motor impairment, brain function changes in the older mice. As the mice got older, just like humans, we start to break down, but they didn't. They found that in the older mice that were treated with resveratrol, they had changes in their liver and muscle tissue gene expression similar to the younger mice. So they were expressing genes similar to the younger mice, and they had basically no bone fractures or any of these age-related declines. So this was a huge moment because essentially the scientists had found a way that the human body regulates gene expressions, and turning this SIRT1 on seemed to be very beneficial towards our gene expression and reduce all these age-related declines in cognitive ability, bone function, all this bone stress, muscle damage, muscle wasting. This could be huge. And SIRT1 was not just its own entity, it also influenced a number of other biochemical pathways in the body. One of them, which is called PGC1 alpha, which is responsible for creating new mitochondria. Resveratrol, which activated SIRT1, also led to an increase in activation of PGC1 alpha, which increased skeletal mitochondria in mice tissue, and SIRT1 deficient mice who were given resveratrol had no increase in mitochondria concentrations, proving that resveratrol directly activated SIRT1 and therefore all the downstream effects such as PGC1 alpha and increased mitochondria. So by this stage, the scientists knew that SIRT1 increased mitochondria content through PGC1 alpha, but also mimics some of the benefits of calorie restriction. So researchers wanted to find out whether other pathways were targets of resveratrol, not just SIRT1, and they did find it. They found AMPK. This is an enzyme which can sense increases or decreases in our AMP to ATP ratio. So basically the energy of the cell, it can pick up and then it can regulate our metabolism based on that. So for example, in times of fasting, AMPK will switch off the high energy consumers in our body, such as protein synthesis, and turn on energy production pathways like lipid oxidation, which is fat burning, to ensure our body has enough energy to run on. Now this is amazing. This one little enzyme can sense, oh, our energy is too low, or yes, our energy is good, and if it is low, then we can use some fat or we can use some glycogen stores to ramp up our energy production. I mean, it's just amazing. And resveratrol was shown to activate AMPK. The way it did this was that resveratrol essentially stopped ATP production in cells. And because AMPK sensed that energy production had shut down, it said, oh, yep, there's not enough energy in the cell. I'm going to have to turn on other mechanisms in the body in order to make energy. One of these mechanisms being the burning of fat. So with mice given resveratrol, their fat burning was turned up. And researchers found a number of other biological effects of resveratrol. It inhibited pro-inflammatory substances that may be involved with tumor growth. It inhibited mTOR signaling, which is a pathway that controls cell growth and proliferation and may improve lifespan when mTOR is actually inhibited, and resveratrol does this. Resveratrol increases a maintenance factor for telomere length. Now, telomeres are the little caps on the end of DNA strands that actually protect against those DNA strands from being damaged. Resveratrol increases the maintenance of these and protects us against various mutations in our DNA that can lead to cancer and tumors. This was highlighted in another study where cells treated with resveratrol showed a 14 times increased ability to remove free radicals, and therefore it could inhibit many cancer growth-like factors. So all of these were huge in the long run because inhibiting cancer growth-like factors may actually reduce cancer rates in humans. But there was one huge problem, is that it's all well and good to have all of these rats and animal studies in the literature, but the problem is that in a normal diet, there's not much resveratrol in here at all. And anything that humans do intake was never really shown up in the blood at all. Like, there was a problem because any resveratrol that we did take through wine wasn't really showing up in the blood. We ingested a lot through the intestine and we actually excrete a lot of it. In one study, 1% of what we actually ate went into our blood. Furthermore, resveratrol is found in low quantities in the human diet and mainly wine. So people got very excited. They thought, yep, we can just drink more. And more. And more. And more. But it's not true because resveratrol is in this, but in very small quantities and not really enough to get into our blood and circulatory system to exert its physiological effects. So that's where the supplementation idea came along. Scientists thought if they can concentrate resveratrol down to a very, very concentrate substance, could this potentially get into the blood more effectively and therefore exert all these positive benefits that they found in the rat and studies of other animals? So there are basically two forms of resveratrol. There's cis and there's trans. Now, trans resveratrol is the most studied and also the more biologically active and the more stable. And pharmacokinetic studies have shown that up to even 2 grams of resveratrol daily with food was pretty well tolerated. But there's a major limiting step in bioavailability is that resveratrol is metabolized by the intestines and liver and pretty much excreted, like almost 90% of it is excreted as waste product. In a number of studies that had been done, especially with capsules, up to 5 grams of resveratrol had only produced an increase in resveratrol in the blood of 15%, which is not very good because that's saying 85% is excreted through the urine. But there was some promise because the study showed that buccal administration through the mouth was the most effective. Even just 1 milligram of resveratrol in 50 milliliters of solution, when you retained it in the mouth, was actually equivalent to a 250 milligram tablet in pill form of resveratrol. That's probably because in the mouth, it sort of skips that first pass metabolism, especially in the intestines, because it's getting directly into the circulation a bit better through the gums themselves. This also makes sense if you think about the science, in that the French diet have a lot of red wine and you don't take red wine in a tablet, you drink it. So I hypothesize that a lot of it has to do with going through the mouth and drinking red wine. A lot of it would actually get through in a buccal way. I think that's why the plasma levels of the French participants who were drinking red wine were actually better in some cases than taking a whole dose of it as a pill form. In fact, the bioavailability of resveratrol from wine and grape juice was 6-fold higher than from tablets. And I suggest this is due to the fact, again, that we take it through the mouth with wine rather than taking it as a tablet and it being metabolized by the liver and intestines and then just excreted, with none of it actually ever getting into the blood. So to conclude, resveratrol is a very potent antioxidant, but there were some problems initially with its bioavailability, and I don't think tablet forms of resveratrol are very useful at all. So if you're going to buy resveratrol, I think it is a good investment. I think the science is strong enough to suggest its use. I think it may have some powerful antioxidant and anti-tumor properties, which is huge. I don't think it will put decades on your life, but I do think that a decreased oxidative stress may make you live a little bit longer, like 1 or 2 years potentially at the end of your life. We don't know, the research isn't there yet, but if the rat studies are anything to go by, then yes, it potentially could increase your longevity a bit. I think the best dose to start would be 1 milligram in some form of liquid solution that you drink like this, leave in your mouth, and then swallow, because that way it's actually getting absorbed through your gums and potentially may increase the amount that actually makes it into your blood rather than a pill form, which has been shown in the literature to be pretty ineffective overall. I'm not saying go out and drink more wine. If you want to get it from wine, go ahead, but also wine obviously has a number of other effects in high quantities. But I do think resveratrol supplementation may help and may just be a nice little vasodilator and may reduce oxidative stress. I don't think it will make us live 60% longer, but it may protect us against some form of oxidative stress. And I think anything that activates SIRT1 is definitely a supplement that has its worth and is definitely something that is not just bullshit. Thank you for watching. I hope I've summarized the science well about resveratrol, and I hope that you can make an informed decision about whether you want to spend your money on this supplement. I really love this. I really love this. And if nothing else, it tastes pretty damn good. See ya.